Good morning, 8th graders. So this is the final little how-to video for how to complete this diagram. So we are working with steps 9 through 12. It looks like a lot, but obviously we have quite a bit we need to label. You have a table that you need to fill in. You have 2 questions on the back. That's it. So let's go through this. So you are going to label all of the following. We need a convergent subduction boundary, a convergent collision boundary, a transform boundary, divergent boundary, a fault line, a mid-ocean ridge, mountains, volcanoes, an event. So a lot of these, because boundaries create these, a lot of them, as you see here, are pointing to the same thing. Okay, now I do not mind which one is labeled which, but you only need one of each. Okay, so for me, this is just where I like to start, but it's totally a you call. I am going to just follow my list. So first things first, I'm looking for a convergent subduction boundary. Now remember, subduction is where, well, convergent is where you have 2 plates coming together. Okay, but with the subduction, you have a difference in density. So you have the super light continental or less dense continental crust and the super dense oceanic crust. So when it comes together, I'm trying to do this like backwards for here we go. Let's see if I can do this. Okay, so when you have them coming together, the dense one falls under and it subducts. Okay, sub like submarine goes under. Okay, so clearly, so we have the oceanic crust, but this is where our subduction zone is happening. Again, doesn't matter which one you want to write on. I'm just going to go with the one on top. So this is a convergent subduction boundary. And because I want to just make sure I don't redo something, that convergent collision boundary. So again, you have 2 plates that are coming together, but they're of the same density. So what's going to happen is that they essentially fight and they create mountains. They push each other up. So we know that this can't be it, even though this looks a little mountainous, because these 2 plates are moving in these directions. Okay, so these are pulling apart. They're not coming together, they're pulling apart. Okay, I don't see, yes, we have mountains, but that also happens with the subduction zone. So here, this is what is happening here. You have continental crust, 2 of them, coming together and forcing upward into a mountain. Okay, so again, this one or this one, I like to just go with the one on top. So we have a convergent collision boundary. Transformative. Remember, transformative is like the San Andreas fault. This is where they are sliding past one another, and because you get those bumps like with your knuckles, they cause for more friction and can kind of hop past each other, creating minor earthquakes. So transformative boundary is where you are looking for 2 boundaries that are going back and forth. Okay? I'm not going to say it again. So, transformative. Transformative convergent is coming together, transformative is sliding past each other, divergent is they're diving away from each other. That's how I remember it, at least. So, by moving away. So, the only place that this is happening in this one is right here because you have the arrows forcing out. So, this is your divergent boundary. Sweet. So now we have the things that can be created thanks to these different boundary types. So we already talked about the fault and how a fault is created kind of like the San Andreas fault, which is at a transformative boundary. It is essentially the line where they meet, that is just kind of like a crack in the earth. And yeah, there's a little bit of a gap because it's deeper down. So if you have something more like this, it's deeper down that they're sliding apart from each other. So our fault goes with our transformative boundaries. Okay. So our fault. Mid-ocean ridge. Well, there's only one ocean. But this is where you have your divergent that's coming apart and you have the new magma coming up to fill it in. So you have a mid-ocean ridge. This is mainly happening at we talk about it at the mid-Atlantic ridge, but it can happen in any ocean. Mid-ocean ridge. Okay. So, this can happen any ocean, but we talk mainly about the mid-Atlantic ridge just because it is the most well-defined, and that is what scientists are actually studying right now to kind of figure out how plate tectonics are working. Mountains. So we talked about mountains. Now we have to understand that you can create mountains at both a convergent subduction and a convergent collision, but we have to understand that mountains only happen at the collision and volcanic mountains happen at the subduction. Okay? It's just what happens, and we can explain that more as we get through. So let's go through the mountains. That only comes with a convergent collision, and that is because you have two plates of the same density coming together and pushing upward. There's not all this pressure happening underneath with magma chambers and things like that to where it's just these plates moving. Okay, so you get just typical mountains. This is how the Rocky Mountains were created or the Appalachian Mountains were created. So we just get regular old mountains at the collision boundary. Okay, so that which means that leaves volcano and vent with a subduction. Oh, and I forgot. I am now just realizing I didn't add trench. Right here. So I will need to remember to do that also on my main copy. So trench is also a thing. Okay, so if we come over here, so let's talk about our volcanoes and our vents. So this primarily happens at our convergent subduction because as you have the two plates coming together and you have that one sliding underneath, now you're starting to build up all this extra pressure here in the mantle of magma because all of this is still trying to force things, and it's just like if you were to put like your hands in water. When you push down, the water needs to go somewhere. Okay, so that's what's happening here. So you get volcanic mountains, but in order to get that like magma to actually come through, you have to also create a vent. Okay, a vent, just like the vents. I'm sitting here and I'm looking at like 3 different vents in my office right now. But it has to be that opening. So this is your opening. This is your vent that allows magma to come through, which leads to the actual volcano. process of elimination, we're left with a trench, okay? And this is where the two plates have met, but, yeah, you can see it a little bit better there. But you get this big old, like, drop-off when it comes to where the plate is subducting under the other. That is a trench. We talk about the Mariana Trench, and places like that, which are just these steep drop-offs. It's like falling off a cliff, just underwater. So, you create a trench. Okay? Awesome. So, now, what you are going to do with the rest of your time is you need to complete this table. Diagram and explain the motions. So, transformative. Diagram and explain can be done literally with arrows. So, what I'm looking for is with your diagramming, I want you to show me in what the direction the arrows are moving. So, transformative, they slide past each other. And that's all I'm going to write here. Slide past. I'm not looking for these big, in-depth sort of things, just common words that you use to help you remember these. Now, features that occur. If you literally just go to where it is, it tells you the feature below it. Okay? So for transformative boundary, the feature that is created is a fault. Okay? And then a real life example. As I went through this, and I'll know the people who actually listened to me, I gave you real life examples. There's one that I didn't talk about, and that's with the divergent. This just happened, a mid-ocean ridge is what is created when there is divergent oceanic plates. But if you have a divergent continental plate, you create rifts. Okay, so we have the I wrote it down in the pages, the Great African Rift, which is literally where the Horn of Africa is being pulled apart, and I think it's the Red Sea or the Black Sea is starting to fill it in. Okay, so, but for this one, you have the San Andreas Fault in California. Okay. California, U.S. Okay? That's all I'm going to be looking for in the remaining 9 boxes. So you should be able to fill that in. Then you need to come back to question 11. What is the difference between continental crust and oceanic crust? This is very important because this is going to relate back to question number 12. Why are continental crust and oceanic crust relevant to the convergent subduction boundary? Okay, so this is going to talk about the difference between convergent, collision, and subduction. Okay? So, awesome. I cannot wait to see everybody's final product when it comes to all of this. But, yeah, awesome. If you have any questions, please feel free to ask your teachers, and hopefully no one else forgot trench like I did. So, I gotta fix that on my computer. So, that's it. Awesome. Thank you so much, 8th graders.